Here we have a couple of examples of how we can use a quadratic equation to solve an area problem. So in the example that we see here, we've got the area of this rectangle is 60 square inches, but we don't know how long the sides are. We know an expression, x plus 3 for the length, and then we know another expression, x minus 1 for the width, but we don't know what x is that makes this problem work. So we need to solve by writing a quadratic equation that we can then factor and figure out what x equals. Now hopefully we know that to find the area of a rectangle, we can do length times width to find that area. So I'm going to do exactly that. So I'm going to have the length, I've got x plus 3, times the width, x minus 1, is going to equal the area, which is 60. So unfortunately, I can't just take these two sets of parentheses, set them equal to 0, and solve. The reason being, my equation doesn't equal 0. So what I'm going to have to do in this circumstance is I'm going to have to FOIL the two binomials. I'm going to have to multiply those out. Then I'll be able to subtract the 60 over, and then I'll be able to refactor the problem to solve for x. So I'm going to use my FOIL technique. So I multiply the firsts, x times x, equals x squared. Then I'm going to multiply the outer, which is negative 1 times x, so negative x. I'm going to multiply the inner, so 3 times x gives me 3x. And then finally, my last, 3 times negative 1 is negative 3. And then that equals 60. So I've got some like terms to gather here, and I need to move that 60 to the other side. So I'm going to kind of do two things at once here. So I'm going to subtract 60 from both sides, and I've got these like terms here in the middle that I'm going to gather. So I'm going to have x squared plus 2x. Remember, this is negative 1x plus 3x in the middle, so that adds up to make 2x. And then minus 3 minus another 60 makes minus 63. And now that equals 0 on the other side. So now we're ready to refactor this problem into two sets of parentheses. So I'm going to set those up. I know that x is going to be the first thing in each of my sets of parentheses. I can see that we're multiplying to make a negative 63, so I need a positive and a negative, but then I'm adding to make that 2 that's in the middle. And so hopefully we can go through our possible factor pairs that multiply to make 63, and we know that 9 times 7 is going to be that pair that is going to produce that 2 in the middle. So I'm going to have a positive 9 and then a negative 7, because 9 plus negative 7 will give me the positive 2 that I need to end up with. And then of course 9 times negative 7 does indeed equal negative 63. So now I'm going to take each of these and set them equal to 0. And so now I'm going to subtract 9 from both sides here. I'll add 7 to both sides over here. And so now we get our two answers. X equals negative 9, and then x equals positive 7. But for an area problem where we're trying to find a number to plug in to make the two sides of a rectangle, we can't have a negative length. Length is always defined as being positive. So in this case, I'm going to have to throw away that negative 9 answer, and so my only result that I'm going to keep is that x equals 7. If it wasn't connected to an area problem, then that negative 9 answer would be just fine. But because we have the context of solving for x, which is part of the side of a rectangle, then we have to throw away the negative. In our second example, we're no longer working with a rectangle, but instead a circle. Now hopefully from our geometry days, we remember that the area of a circle is pi times the radius squared. So we're told the area. We have an expression for the radius, so we're going to use those two and plug them into this equation. So in place of a, I'm going to put 81 pi, and then I still have pi on the other side, times, and then my radius is x minus 3, so that's going to be squared. So I have much the same thing as I have in the previous question, where I'm going to have to multiply out, I'm going to have to FOIL out the x minus 3 squared, and then bring that 81 over to the other side. But before I do that, I'm going to divide both sides by this pi. This way I won't have this extra number, this 3.14159 that goes on forever hanging around in my problem. Since I've got it on both sides, I can go ahead and divide it away so I no longer have to deal with it. So on this left-hand side I've got 81. On the right-hand side I now have x minus 3 squared. But I need to write this out as x minus 3 times x minus 3. I have to remember that I have to FOIL this. I can't just square the individual pieces. Exponents don't distribute. I can't do this. It's a big no-no. So I have to use this full FOIL technique to multiply out what I have here on the right-hand side. So I still have this 81, but now I'm going to FOIL. So I've got x times x gives me x squared. My outer gives me a negative 3x. My inner gives me another negative 3x. Those don't cancel out. They're just going to add together to make a negative 6x in a minute. And then finally I've got negative 3 times negative 3 that gives me positive 9. So just like I did on the previous question, I'm going to try to do two things at once. I'm going to move this 81 to the other side so I get my 0 over here, and at the same time I'm going to combine my like terms over on the right hand side. So I still have x squared minus 3x and minus 3x, as I already mentioned, is going to be minus 6x, and then finally I've got 9 minus 81, which is negative 72. So now I need to factor. So I can go ahead and scroll a little bit here, give ourselves a little room. So I've got my 0 equals, I'll set up my two sets of parentheses. As always, we've got x as that first piece in each set of parentheses. And then I'm going to multiply to make negative 72. So I need a positive and a negative. Since I need to multiply to make a negative, I need one of each. And then I have to go through my factor pairs of 72 to find what has a difference of 6, since one's going to be positive and one's going to be negative. And so we can use a calculator to help us out. We've got 1 times 72, we've got 2 times 36, we've got 3 times 24, we've got 4 times 18. Again, none of those are working because we don't have a difference of 6 between them. But if we jump to 6 times 12, hopefully we see that we've got that gap of 6 between those two numbers. And since our middle number needs to be a negative, we're going to make that bigger number than negative. So minus 12 and then plus 6. So now we can take these two factors and set them equal to 0. And so then we've got to subtract 6 here. So we get x equals negative 6. But for the same reason that we saw in the previous example, we can't have a negative value for x in this problem because that would mean our radius would turn out to be a negative number. So I'm right away going to throw that out. And so then my answer is going to come from this other one where I add 12 to both sides, and so I get x equals 12. So that's the value of x that makes this problem work.